Good day and welcome to today's basic technology class. For today, we'll be looking into gears. All right. So, gear are the most used method of transmitting energy or power in mechanical engineering. Gears form vital elements of mechanisms in most machinery, such as vehicles, marine engines, rolling mills, and many more. All right. So, I'm going to refer back to our last two topics, which is what are drive mechanism. So, we said basically we have three major types of drive mechanism. The first one is the belt drive, the second one is the chain drive, while the third one is the gear drive. So, for today, we are going to expatiate more on gear drive and its importance to technology at large. All right. So gears are made using metallic and non-metallic materials. Yeah, that's just it. So anytime you hear the word gear, so don't just feel it's only about metals. No, non-metallic objects can also be used to fabricate what gear. Example, your wristwatches. Yeah, your wristwatches or your work clock, the work clock at home. You know, you try to adjust the hours or minutes, isn't it? So the mechanism inside that area where you adjust your work clock at home are made of gears, and they are majorly made of what? Plastic gears. So aside from that, if you have actually maybe pieces an unused radio, yeah, an unused radio in your house, so you are going to find several plastic gears inside of it. All right. So that is that about that. So the material used for making gear depend on the condition it will be subjected to, such as noise, vibration, wear and tear, and many more. That's just it. So before I actually decided on what type of material I'm actually going to use for the manufacture of my gear, so I need to actually put this into consideration. For what purpose? Yeah, what purpose is that gear serving? For example, now let's assume I'm going to apply the gear in a bike. All right, so you won't expect me to go for a plastic material or a wooden material. No, it won't work. So what am I going to go for? I'm going to go for what? A metallic what? Material. All right. So likewise, we also have several machines that make use of alloys of metal as their gear, such as brass or bronze. All right. So they are metallic or they are metal alloys. So several materials can be made use for gear depending on what you want to use it for, and depending on the amount of noise, vibration, wear and tear. For example, now in case of plastic gear, yeah, it is going to that is actually used where there is tolerance for little or no noise. That's just it. If you make use of plastic gear, then there is tolerance for little or what or no noise, or unlike when you make use of metallic gear, which is going to generate some reasonable amount of sound or noise. All right. So that is that about that. So the gear teeth must be of equal spacing. Yeah, it must be of equal spacing so as to enable their interlocking. All right. So the gear teeth must be cut with equal spacing so that when two gears engaged each other, they can engage properly and produce uniform motion. That's just it. So, and that's the major reason why you need to ensure that the teeth of the gear are what are uniform, then are equal. All right. So also I have tiny devices such as wristwatch use tiny gears, while there are large gears for large machines. All right. Gears are majorly used for changing speed, power and direction between an input and output shaft. All right. So for example, now in your bicycle, so if you have at your rear wheel, yeah, so if you have more than one sprocket there, then it's a bicycle whereby you can actually change the speed. Yeah, so even in automobiles or in motorbikes, motorcycle, you know, you change the speed from gear 1 to gear 2, gear 3, stuff like that. All right. So that is changing of speed. While that of direction applies to several industrial machine, and also, yeah, your work clock and your wristwatch. So the gears there are actually used to change the direction. Yeah, to change direction. All right. So, and also in automobile also, you know, car can move towards the front and backward in the reverse motion, yes or no? So that is also made possible with the help of what? With the help of several gears. All right. So that is that about that. So the arrangement of two or more gears in a shaft to transmit motion is called gearing. So take note of that. Why the engagement or connection of gears, yeah, engagement or connection of two or more gear is known as what? Is known as meshing. So I think we said this in that particular class which we treated then. All right. So transmission of power by gears is done through gearing and meshing of gears. Yeah, it's done through gearing and meshing of gears. So during gearing, the gears are divided into two, which are the driver gear and the driven gear. I think I've actually explained what the driver is actually all about and what the driven is actually all about. So listen, the driver is where power is being generated from. All right, that is the input. So why the driven is the output. All right, is where the power is being what transferred to, is the output. All right. So take a look at this. All right, driver gear is the gear which generates motion or power, while the driven gear is the gear power is transmitted to. So I made mention of this earlier on. So when the driver and driven gear mesh to produce motion, they usually rotate in opposite direction. So you can actually practicalize this also. Just look for two mineral cork, your Pepsi cork or your Fanta cork, which you call canters. You call it canters. So it is called cork, C-U-R-K. Yeah. Look for mineral corks. You know the edge of those mineral corks are what uh they are in a zigzag like manner, so they are in a gearish. So just try and practicalize this. So put them together, you will see that if they are going to drive each other, they are going to move in what opposite direction. But in some cases there is need for the driver and driven gear to rotate in one direction. Yeah, in one direction. So what are you going to do? An idler, which is a third gear, is introduced between the two machine gears. So gears are more importantly used for changing directions in machines as we have in vehicles. So take a look at this picture. So take a look at this picture. So that's a driver and a driven gear. You can see gear A is moving in an anti-clockwise direction while gear B is moving in what, in clockwise direction. So that is how a normal gear system works. If you mesh them together, if you engage them, if you engage the mesh the connected gear, then they move in what, they move in separate direction. But take a look at this second picture now. So take a look at gear A and gear C. You will see that what, they are moving in the same direction. So what makes them to move in the same direction? That is what, that is gear B. So the gear B in between them is known as what, is known as the idler gear. So it enables your gear to what, your most important gears to what, to move in the same direction. And this is usually applied in automobiles. Yeah, that is why you can have the drive gear or what, or the reverse gear. All right. So that is that about that. So from there we have types of gear. Then I actually made mention of this inside your automobile or your motorcycle. Yeah, that particular device that makes your motor to move, you understand, it is known as the gearbox, all right, or the transmission system. So it is inside that gearbox you have several gears, all right, you have several gears. So which is known as what, the gear train. All right, so that is that about that. So each of those gears forms a gear train or what, or a transition box. So we have the same thing in your motorcycle or your what, or your automobile. All right, so we have several types of gears. So the very first one is the spur gear. So this is how a spur gear actually look like. The second one is the worm gear. So this is how it looks like. The third one is the sprocket gear. You are very familiar with this in motorbikes and bicycles. All right, so this fourth one is the bevel gear. All right, so that's a bevel gear. So the fifth one is an helical gear. So that's an helical gear. The sixth one is a rack and pinion gear. So rack and pinion gear is actually used to convert rotational motion into linear motion. So example of this is typically shebi, you know, if your daddy owns a car, yeah, if your parents owns a car, all right. So the door, yeah, the glass at the door, the window of your daddy's vehicle or your mommy's vehicle, you know, you wind up and you wind down, yes or no. So if you make use of the automatic system whereby you press the button and it brings it to and fro, no wahala. But if you have actually seen the manual one whereby you use your hand to roll it up and down, you will take note that your hand is moving what, in a rotational manner, meanwhile the glass is what, moving in a what, in a linear motion. So a rack and pinion gear is actually used there for majorly for car windows glasses. All right, so a rack and pinion gear is majorly used there. So then we also have the external and internal gear. All right, so those are the pictures. All right, so from there we move to use of gear. So gears are used to change the direction of motion. Rotation gears such as rack and pinion gears are used to change or convert rotary motion to linear motion. That's just it. So they are used to change the direction of motion. All right, so like that rack and pinion. So uh the first one is one moving in a rotational manner, while the second one is moving in what, in a linear manner. So that is that about that. So number two, gears are used to change the speed of a machine or increase, as used in our cars and other automobile. I think this one is well explanatory, right? To change the speed of your vehicle, so you move from the lower gear, which is gear 1, to the what, to the higher gear, which is either gear 4 or what, or gear 5, to higher speed. Sorry. So the third one is gear reducers are used for gear reduction in machine to increase the torque of the machine. So one thing is this: in most automobile, the engine actually gives out high power but low torque. Torque is the rotational force. Yeah, the rotational force transferred from the engine, all right, transfer from the engine to the wheel. So that rotational force is actually small. So what do we use to increase the speed of your vehicle, to increase the torque? We increase the torque by the use of what? Several gears. By the use of several gears, all right. So don't worry, by the time you get to gear ratio, you are going to actually understand this particular area very well. So gears such as sport gears are used to transmit power from one shaft to another, all right. So bevel gears are used for changing the direction of what? Of motion. So then we have advantages of gear technology. Why do we need to make use of gear? So the first one is they have long lifespan when properly lubricated than other drives. That's just it. So gear, either plastic or metals, they last for a very long time. They are durable. That's just it. Number two, gears do not suffer slippage. So unlike in belt drive, in belt drive, by at times the pulleys will be rolling while the belt is going to slip off, but such doesn't occur in a gear drive. Such doesn't occur. The third one is that gears are used where precise timing is desired. So that is why in automobile engines we have what is called a timing belt, all right. So those of you who are familiar with maybe the mechanics, so you can ask them about this. So where precision and timing is desired, we make use of what? Of gear, because what? There is little space. Yeah, there is little, because gears are closely related to each other. So because of that, so there is little space for interference. Yeah, there is little space of interference of external causes to actually destabilize the timing or put any disruption, all right. So the fourth one, they can be used for a wide range of power transmission, all right. The fifth one, they are used to drive heavier loads than other devices. That's just it. So the cranes, the heavy duty machines, yeah, they have a gear in them, all right. They have a gear in them which actually makes them lifting heavy objects possible. So gears have higher efficiency and simple operation. Yeah, they are very efficient. They have little or zero tolerance for error. Yeah, for error or inaccuracy. So that is that about that. So from there we move to gear ratio and speed ratio. So gear ratio is the ratio of the number of teeth of driver gear, that is the efforts, to the number of teeth of driven gear. So the formula for gear ratio is number of teeth on driver gear all over number of teeth on driven gear, all right. So which is what? N1 over N2. Example, find the gear ratio in the diagram below. So take a look at this particular picture. So the first gear is what? Is 30, is 60, is having 60 teeth, while the second gear is having what? Is having 30 teeth. So I'm going to revert back to that explanation. I said that to change speed here, if the engine produces high power but low torque, so how do we increase the output of the speed transfer to the wheel of the vehicle? We make use of what? Of gear. So let us assume that gear of 60 teeth is the one that comes from your engine. So to transfer it to the wheel, what do we use? We make use of what? Of a smaller gear, yeah, which is 30. So take a look at this. You know that by the time gear 60 makes one complete revolution, gear 30 is going to make how many revolution? 2. So which means you've actually increased the speed coming from what? From 60, then coming to 30, it moves what? It moves twice. That is, when 60 moves a complete revolution, 30 moves how many times? It moves twice. So you've increased the speed there, which means if the gear 60 moves twice, then gear 30 is going to move what? 4 times. So that is how the speed of mechanisms are being increased, making use of gear. So back to gear ratio. So what's the answer for this particular question now? So this is distance moved by effort over distance moved by load, that is 60 over 30, that is gear A, which is the driver, all over what? All over driven. So and the answer is was 2:1. So that is that about that. So we move to speed ratio. This is the ratio of rotation per minute of the driven gears to the rotation per minute of the what? Of the driver gear. So that rotation per minute, all right, it can also be known as what? Revolution per minute. So that is REV/MIN. So if you see something like that, it's still the same thing. Rotation, revolution per minute are still the same thing. They are the unit for what? For speed ratio. That's the unit for speed ratio, all right. That is the unit for speed ratio. So we have a very good example here. So the speed of a driving gear is 80 rpm and that of a driven gear is 20 rpm. What is the speed ratio of the gear system? So as our formula says, driven gear over what? Over driver gear when it comes to speed ratio. So and we have the answer here. So that is what? 1:4. 1:4. Let's move on. Here we move to there are instances where the gear ratio is equal to the speed ratio. So yeah, there are scenarios whereby the gear ratio is equal to the what? Is equal to the speed ratio. So take a look at this instance. In a given gear system, the driver gear with 50 teeth has the speed of 25 revolution per minute. The driver gear drives another gear which has 25 teeth. What is the speed of the driven gear? So for you to tackle our problems on gear and speed ratio, please take note of the grammatical terms used therein. Yeah, it's more or less like a word problem. So if you made mistake in interpreting the grammars therein, then you might actually falsify your final outcome. So take note of that. So driver gear teeth N1 is what? Is 50, while the driver gear speed is what? Is 25 revolution per minute. So the driven gear teeth is what? Is 25 teeth. So while the driven gear speed is what? Is unknown. Alright, so applying that formula, our N1, that is driver gear teeth over what? Over driven gear teeth equals to what? Equals to driven gear speed over what? Over driver gear speed. Alright, so and that is how we have this. So we are going to make our R2 as the subject of formula. So we have this, then our final answer is what? Is 25. So as you can see, so the gear ratio here is what? Is 25, while the speed ratio is also what? Is also what? 25. So that is the driven gear ratio is 25 and the driven gear speed is what? Is also what? 25. So that is that about that. So from there we move to friction between meshing gears and function of lubricant. All right, so friction is a form of force that opposes relative or sliding motion in contact with surfaces. That's just it. So since gears have to mesh or engage with each other to produce motion, frictional force is called into action. Yeah, so if two surfaces are actually rubbing each other, so there is the presence of friction, which is going to reduce, yeah, the efficiency of the two surfaces, which is going to reduce the motion. So how do we avoid that? How do we avoid that? We are going to look at that later on. But one thing is the friction causes excessive generation of heat, wear and tear. So that is it. So maybe if your dad actually drive his car to and fro, after parking it, just try to touch the rim or the wheel of that vehicle, you see that it is what? It is usually hot, and that is as a result of what? As a result of friction. So therefore, if friction is allowed, friction will eventually cause wear and tear of the gear teeth or total breakdown of the system. That's just it. You can actually rub your palms together. Yeah, rub your palm together. By the time you rub them together, you will take note that what? It is generated, yes or no. That's just it. But if you want to negate if you want to negate the friction in between your palm, just apply lotion. Yeah, apply lotion, something like a cream on your palm, then rub it together. You will take note that it will just be what? It will just be sliding over each other without generating any what? Any heat. So and that is a means of what? A means of negating or removing friction from our devices also. But instead of us applying cream, you can apply cream to mechanical objects. So what do you apply? We apply what is called a lubrication oil or lubricant oil. So for gear we have what is called what? The gear oil. So just take note of this as we continue. So I explained this just now, that lubrication method of reducing friction is very useful in gear system. Lubricant is used to lubricate the gear by injecting it into the gear container, so that when two gear teeth engage to transmit power, they rub against one another. But lubricant oil helps to reduce friction. I explained it. So you can practicalize this by putting a lotion on your palm, then rub it together. You will see that no heat is going to be generated. All right. So when applying lubricant oil, it is very important to use proper lubricant for all the moving parts of the machine to achieve a better result. So I made mention of this. So because I said if you put lotion or cream on your palm, so don't try and put lotion or cream on gears. Yeah, on gear. So every gear, depending on the material, have their own standard or specified lubricant. All right. So the lubricant oil used for gear is also known as what? As the gear oil, and should only be used on gear. All right. So from there we move to lubrication of moving parts regularly is very important for the following reason. Why do I need to lubricate moving parts of my gear? So the first one is to prevent the gear surface from corrosion. That's just it. Yeah. So it prevents corrosion, because if lubricant is on any part of your moving system, then it won't allow the absorption of liquid content or impurities. That's just it. So number two, it prevents wear and tear of moving parts. Yeah. Number three, it reduces frictional effect. Number four, it serves as a cooling agent to reduce the heat generated. You'll be amazed. I thought water is a cooling agent. No. For engines, for engines here, for moving parts in engines, the oil act as what, as a lube, as a cooling agent for them. It acts as a cooling agent for them, aside from the what, from the water journey. So if you don't know, have this at the back of your mind now. All right. So the fifth one is, it serves as cushion for the machine by filling the space between metal parts. Yeah, in between two surfaces, no matter how tiny the gap between them is, yeah, there's always a space there. There's always a space there. So the lubricant actually fill that space. It fill that space between them. All right. So, and that is the end of today's class. That is the end of today's class. So these are the assignments which you have today on your screen. Ensure you do them right in your notes, and have a good day. Have a good day. Thank you.